I want you to try and visualize the origin of life for a second.
Oh, I think we all have that exact same picture in our heads, right?
Right. The default image we all carry around is usually that warm, muddy puddle on some prehistoric Earth, and you imagine a lightning bolt hitting some primordial soup.
Yeah, some chemicals fizz together.
Exactly. And suddenly, out of nowhere, the first building blocks of life just spontaneously arrange themselves. I mean, we treat Earth as this isolated, self-contained laboratory that just, well, happened to pull off a miracle.
Which is a nice story, but it fundamentally shrinks our perspective when we assume Earth acted alone.
Yeah, and that's exactly why we're doing this deep dive today. We're looking at a fascinating new paper by a researcher named Melvin Sewell from the Cosmic University of Echo Rift Studies.
Right. The paper is titled Courier-Bodies, How the Universe Delivered the First Ingredients of Life. And it basically argues that those essential prebiotic molecules, they weren't just some local spontaneous accident.
No, not at all. Our goal for this deep dive is to explore how these incredibly fragile ingredients actually survived the brutal expanse of the early universe to, ultimately seed our planet.
It's blending hardcore astrobiology with an almost mythological narrative. They were the payload of this unimaginably vast, highly orchestrated cosmic logistics network.
Which completely upends how we think about our own biology. But before we understand the journey, we have to look at the cargo itself, right?
Absolutely. Sewell's research highlights some very specific prebiotic cargo. We're talking about meteoritic amino acids, nucleobases, and especially cometary sugars.
And reading through this, the sheer thermodynamic impossibility of these molecules surviving the early universe is what really stands out to me.
Oh, without a doubt. I mean, we aren't talking about chunks of iron here,
Yeah.
or even dormant extremophile bacteria.
Right. These are highly fragile chemical structures, like if you expose delicate cometary sugars to the raw, unfiltered radiation of the early cosmos.
And the extreme thermal cycling.
Yeah, exactly. They shouldn't just degrade. I mean, their molecular backbone should be completely shredded by cosmic rays.
The ambient conditions of the early universe were fundamentally hostile to chemical complexity. The ionizing radiation alone would just shatter the carbon bonds necessary to form anything resembling an amino acid.
Right.
If these molecules were just drifting freely or, sitting on the surface of a standard asteroid, they would denature and disintegrate millions of years before they even encountered a planetary gravity well.
So they couldn't just float here.
No, not a chance. Sewell isn't just asking how life got here. The paper is asking how the underlying biochemical architecture avoided being literally erased by the universe that created it.
Here's where it gets really interesting, because Sewell doesn't just point out the problem. I mean, the paper introduces the actual mechanism that allowed this fragile cargo to survive.
The shipping containers, basically.
Yeah. Think of these molecules as the ultimate cosmic meal prep, incredibly fragile. To protect them, the universe used what Sewell calls rift-forged dynamics, operating inside specialized substrates known as Courier-Bodies.
The terminology is dense, but it's precise.
It is. And looking at the physics Sewell proposes, this isn't just about an asteroid acting as a rock shield. It's like a high-tech, blast-proof shipping container forged in intense cosmological conditions. The environment inside a Courier body seems entirely decoupled from the thermodynamic chaos outside of it.
Decoupled is the vital word there. Rift-forged dynamics refers to the localized cosmological processes that actually synthesize these Courier bodies.
Wait, synthesized how?
Well, we're talking about energetic anomalies near early cosmic rifts. These were immense localized pressure zones, and that pressure didn't just compress dust into rock.
Oh, I see.
Yeah, it forged a crystalline lattice structure. The intense energies effectively baked the exterior of these bodies into a density that acted as an almost perfect Faraday cage and a thermal insulator.
Wow. So the intense hostility of the early universe is actually what created the protection in the first place. The extreme pressure forces the rock into a lattice that, isolates the internal chamber.
Exactly. The external chaos dictates the internal calm. The Courier body forms around the prebiotic molecules, and because of that dense crystalline exterior formed by rift-forged dynamics, the internal environment just stabilizes.
It locks them in.
It does. It locks the cometary sugars and nucleobases into a state of structural preservation. The molecular bonds are shielded from cosmic rays, the thermal state is locked, and the molecules are effectively put into biochemical suspended animation.
Okay, let's unpack this, because this is where I start circling Sewell's terminology with a red pen.
Oh, really?
Yeah, I have to step into the skeptic's corner here for a minute. So we know the cargo, And we have these thermally isolated Courier bodies acting as the shipping containers. But Sewell insists on calling the space they travel through the SH1 substrate framework
Yeah.
and says it operates under echo-rift cosmology.
Mm-hmm.
I mean, I read those sections multiple times, and I just have to ask, is Sewell just aggressively rebranding outer space?
That's a common initial reaction.
Right. Like, are we just taking the mundane reality of rocks flying through a vacuum and dressing it up in all this multiversal jargon to make it sound more profound?
Well, what's fascinating here is that your skepticism assumes the void of the early universe was actually empty or uniform.
I mean, wasn't it mostly just empty space?
Not exactly. Sewell's pushing back against that exact classical assumption. Echo-rift cosmology argues that early spacetime wasn't this isotropic, featureless vacuum where rocks just scattered randomly in all directions.
Okay, so what was it then?
The SH1 substrate isn't just empty space. It's a description of physical conductive pathways formed by topological defects in early spacetime, or potentially dense filaments of dark matter. It acts as a highly structured, multiversal medium.
But calling it a framework or a substrate, it almost implies a level of directed design, like a highway system.
I wouldn't say designed.
Sure, gravity exists, obviously, and objects follow gravitational wells. But phrasing it as a conductive medium makes it sound almost teleological. It sounds like the universe built a road specifically for these Courier bodies, which, I don't know, edges a little too close to sci-fi for a hard astrophysics paper.
It's not teleological, but it is thermodynamic. Think about water flowing down a mountain.
Okay.
The mountain doesn't design a riverbed with the intention of moving water, right? The water simply follows the pathways of least resistance that are already carved by gravity and geological structure.
Yeah, that makes sense.
Well, the SH1 substrate functions similarly, just on a cosmological scale. The early universe had a specific architectural framework. Things like gravitational flex tubes and energetic currents. The Courier bodies didn't just blindly drift, they were caught in these pathways.
Meaning their trajectories weren't purely random statistical noise, they were funneled.
Funneled is a much better way to conceptualize it than a highway. The dense filaments of the SH1 substrate acted as a conductive medium, physically guiding the distribution of these Courier bodies across vast cosmological distances.
Oh, wow.
Yeah, the spatial structure itself facilitated the transport. Sewell's math attempts to map these pathways, showing that the delivery of prebiotic material wasn't just some lucky lottery ticket. It was a consequence of the universe's underlying topology.
That dramatically changes the math of astrobiology. If the universe has a structural bias toward funneling prebiotic material along specific filaments, space becomes an active participant in biological distribution, rather than just a cold, passive void.
Exactly.
But following that logic brings us to a massive, glaring wall. Because surviving the journey across the SH1 substrate is only half the battle, right?
The drop-off.
Yes. The cargo still had to survive the landing on a chaotic, volatile early Earth. Let's assume the Courier body survives the trip. It funnels perfectly toward Earth. Sewell places the arrival of this cargo right in the middle of the heavy bombardment period.
Which is typically viewed as the absolute worst time for complex chemistry to arrive on a planet.
To put it mildly, I mean, we're talking about an era when Earth was being relentlessly pummeled by massive celestial bodies. The kinetic energy of these impacts melted the crust, turning the surface into a churning ocean of magma.
The standard interpretation of the heavy bombardment is that it was a completely sterilizing epoch. Any early oceans would have boiled off.
Right.
Any fragile molecular chains trying to organize themselves on the surface would have been vaporized by the sheer thermal and concussive force of the impacts. It's usually seen as a hard reset button for planetary evolution.
So what does this all mean for Sewell's theory? We just established that cometary sugars and amino acids are so incredibly delicate they required a blast-proof, crystalline cosmic Faraday cage just to survive the ambient cold of space. How do they possibly survive a collision with a magma-covered Earth at 40,000 miles an hour? A localized thermal pocket inside a rock won't save you when the entire rock turns into plasma upon impact. The delivery mechanism itself should instantly obliterate the cargo.
Well, it does obliterate the cargo, physically.
Wait, what?
Yeah, physically it's destroyed. But Sewell introduces a unified model called pattern stabilization to explain how the molecular continuity survives the physical destruction of the Courier body. And this is arguably the most radical part of the paper.
Okay, I'm listening.
When the Courier body impacts the planetary surface, the immense kinetic energy and heat vaporize the outer crystalline shell. And yes, the physical prebiotic molecules inside are often instantly destroyed.
But if the molecules are destroyed, the cargo is gone. How does that seed a planet?
Because the information survives. The Courier bodies act as carriers of molecular continuity across cosmological scale.
It's like downloading a massive file via a rugged hard drive. Even if the outer shell gets smashed during the impact, the data is preserved.
Exactly. Pattern stabilization operates on the principle that the immense heat and pressure of the impact flash-forge the surrounding terrestrial minerals. For a microsecond, as the prebiotic molecules vaporize, the kinetic shockwave imprints their precise structural geometry into the rapidly cooling silicate glass and superheated substrate of the early Earth.
Wait, really? Like a fossil impression?
Conceptually, yes, but on a biochemical level.
Okay, let me visualize this. Instead of a seed gently landing in soil, it's like taking an incredibly complex, intricately carved wax seal and smashing it into semi-molten iron with a sledgehammer.
That's a great analogy.
The physical cometary sugar or nucleobase is instantly vaporized by the heat and the force. It's totally gone. But the force of the strike was so immense and the cooling of the iron so rapid that the intricate pattern of the wax seal is perfectly stamped into the metal.
Yes, exactly.
The terrestrial minerals form a perfect structural negative of the vaporized organic molecule.
That is a highly accurate way to frame Sewell's chemistry. The physical vehicle is destroyed, and the original cosmic atoms might scatter, but the structural pattern, the molecular blueprint, is transferred to the planetary environment.
Yeah.
The receiving station, in this case Earth's primordial chemistry, immediately begins interacting with these flash-forged negative molds. The local Earth-based chemicals naturally bind and fill these molecular templates, effectively rebuilding the complex sugars and amino acids using local materials.
So the heavy bombardment isn't a sterilizing apocalypse. It's the ultimate seeding event. It's the energy source driving the biochemical download. The kinetic energy is the hammer that stamps the cosmic blueprint into the terrestrial crust.
It completely flips our understanding of planetary habitability. The violence of the impact is the mandatory catalyst. Without the extreme kinetic energy of the heavy bombardment, the Courier bodies would just sit on the surface like inert rocks, trapping the molecules inside their crystalline lattices forever.
Because they're sealed so tight.
Exactly. The impact is required to shatter the vault and transcribe the molecular continuity from a cosmic scale to a planetary scale.
That resolves the paradox beautifully. We still get our primordial soup, but the recipes for the complex molecules in that soup were violently and purposefully transcribed from a cosmic template.
And it's at this point in Sewell's paper that the tone dramatically shifts.
Yeah, I noticed that. After grounding us in this intense micro-level physics, rift-forged dynamics, topological funnels, flash-forged pattern stabilization, Sewell zooms all the way out, we start looking at how this theory changes our philosophical understanding of life's origins.
If we connect this to the bigger picture, Sewell is taking the existing framework of panspermia.
That's the theory that life exists throughout the universe and is distributed by space dust and meteoroids, right?
Right, and elevating it mathematically through what the paper terms a category-theoretic structure.
Okay, I have to admit, I found this section incredibly dense. Category theory is a branch of mathematics. It's usually completely divorced from biology. How does Sewell apply it to the heavy bombardment?
Well, in mathematics, category theory focuses on mapping the relationships or morphisms between seemingly unrelated structures. It's less about the objects themselves and more about how different systems mirror each other's logic.
Okay.
Sewell applies this to astrobiology by arguing that the delivery of life isn't just a physical sequence of events, it's a fundamental structural property of the universe. Sewell maps the physical transport mechanisms, the SH1 substrate funnels, and the pattern stabilization directly onto the mechanisms of biological evolution.
So the way a Courier body adapts its internal environment to survive a rift is mathematically similar to how a biological cell adapts to its environment.
Yes. Sewell argues that the universe uses the same structural logic to transport prebiotic data across galaxies as a strand of DNA uses to transport genetic data across generations.
That is mind-blowing.
The physical cosmos and biological life are operating on the exact same mathematical architecture. And this is where Sewell makes the leap to integrating empirical astrobiology with a mythic scientific narrative.
That phrase, mythic scientific narrative, is such a provocative oxymoron. I mean, science is supposed to dismantle myth, not integrate with it.
Right, but look at the resonance.
Exactly. As I read Sewell's reasoning, it started to make sense. For thousands of years, across completely disconnected cultures, human beings have independently generated the exact same core myths.
God's bringing fire down from the heavens.
Yes, or sacred seeds falling from the sky to spark human existence. Prometheus stealing fire from Olympus and surviving a brutal journey to hand it to humanity. We have always had this deep psychological intuition that our vital spark was delivered, not spontaneously generated. It's like the Courier-Bodies are the modern scientific equivalent of those mythological gods.
And Sewell's point is that this intuition isn't a childish fairy tale we need to outgrow. It's a cognitive reflection of our actual category-theoretic origins. This raises an important question about how human cognition processes deep time and multiversal scales.
How so?
We simply do not have the neurological hardware to intuitively grasp a multi-billion-year, multi-galactic causal chain of thermodynamic pathways and silicate glass flash forging.
The raw data is too vast. It exceeds our bandwidth.
Exactly. When a scientific reality involves billions of years in cosmic topology, empirical data alone fails to resonate with human consciousness.
We need the story.
We need both the empirical data, the amino acids, and the narrative structure. The hero's journey of the Courier-Bodies surviving the brutal cosmic rifts, navigating the dark topological funnels of the SH1 substrate, and ultimately sacrificing its physical form in the fires of the heavy bombardment to pass on the molecular blueprint of life.
Wow.
Sewell argues that a mythic framework is actually the most accurate and mathematically rigorous way for a human brain to conceptualize our origins.
It bridges the gap between the equation and the experience. Sewell is offering us an origin story that is both rigorously backed by astrophysics and deeply satisfying on an ancient psychological level.
It completely redefines our relationship to the cosmos.
It really does. We aren't an isolated anomaly that got lucky in a local mud puddle. We are the successful terminus of an unimaginably ancient, highly structured intergalactic effort.
The Earth transitions from being a solitary inventor of life to being an incredibly fortunate recipient. It provides a cohesive, unified mechanism that connects the macrostructure of the universe directly to the microstructure of our DNA.
To pull all these incredible threads together, Sewell's paper takes the most fragile cargo imaginable, cometary sugars and nucleobases, and explains their impossible survival through rift-forged dynamics, where intense cosmic pressures bake protective, localized thermal pockets inside Courier-Bodies.
A literal blast-proof shield.
Yeah. And those bodies didn't just drift in a vacuum. They were actively funneled along the dense conductive pathways of the SH1 substrate. And when they finally reached a chaotic early Earth, the catastrophic violence of the heavy bombardment wasn't a sterilizing event.
No, it was the key.
Right. Through pattern stabilization, the sheer kinetic force flash-forged the molecular blueprints of life into the cooling terrestrial crust, maintaining molecular continuity across cosmological scales, transferring the data just as the physical vehicle was destroyed.
It takes the chaotic, violent history of the early universe and reveals a deeply ordered mathematical continuity. It's a profound shift in astrobiological modeling.
It really is.
Yeah.
So to you listening, the next time you walk outside and look up at a clear night sky, I want you to try and discard the idea of space as a cold, empty vacuum. You aren't looking at a void.
You are looking at the SH1 substrate.
Yes. You are looking at the remnants of a vast, highly structured, multiversal highway that funneled the very building blocks of your DNA through the dark. The universe didn't just tolerate our existence. Its underlying topology actively delivered it.
And remember, the structures that delivered those Courier-Bodies didn't disappear when Earth's oceans cooled. Those gravitational funnels and thermodynamic pathways still exist.
Which leaves us with one incredibly haunting thought. If the SH1 substrate is a universal framework and pattern stabilization ensures that molecular blueprints survive catastrophic kinetic impacts, what else is being funneled out there right now?
Oh, that's a wild thought.
Deep in the cosmos, on some unseen, barren exoplanet, what intricate molecular blueprints are locked inside a crystalline Courier-Body, just sitting in the dark, waiting for the sky to fall and spark a whole new genesis? Something to think about.